Hello students, in our last lecture we have discussed few questions of chapter 1. Okay, so few more questions we are going to study. So let's start with electric field on equatorial plane. Electric field on equatorial line, or you can say equatorial plane. Okay, so first of all, what is equatorial line? Equatorial line is a line passing through the center of the dipole and perpendicular to its axis. Equatorial line is a line passing through the center of electric dipole and it is perpendicular to axis of the dipole. Okay. Second important thing, please hear me carefully. Listen. Dipole has only one and one axis, but it has infinite equatorial lines. Okay, if you think properly, you will realize dipole has only one axis, but it has infinite equatorial line. Okay, it has infinite equatorial line. Here we have to discuss electric field on equatorial line. Okay, this is very important question, 3-marker question. So please pay your attention. Suppose this is the axis of dipole. Okay, plus q charge, minus q charge, center. Okay, this is equatorial line. Suppose this is the point P where we have to find electric field. It is at distance r from the center of the dipole. ठीक है. Now listen. Electric field due to positive charge E plus. Electric field due to negative charge. Okay. Now we know that electric field of positive charge is in the direction radially or outward, and for negative charge it is radially inward. So direction of electric field of positive charge, radial direction but away from the charge, and for negative, radial towards charge. Okay. So now we have to, because electric field is vector quantity, so we need resultant vector. Okay, so here we need vector addition of electric field due to positive charge and electric field due to negative charge. Okay. So definitely here we have to divide both vectors into component. Now you can see electric field due to positive charge, it is in second quadrant. So if I divide it into components, the horizontal component is in negative direction, vertical component is in positive direction. Similarly, electric field of negative charge, it is in third quadrant. So whenever a vector is there in third quadrant, and if we divide this vector into components, so you will find both components, vertical and horizontal, both are in negative direction. Okay. So it is like this. Suppose this angle is theta, then definitely this angle is also theta. Distance A, distance A. Okay. Now this distance, according to Pythagoras, it is r square plus a square. Okay. So this angle is theta, this angle is also theta. So E plus cos theta, E minus cos theta. This component is E plus sin theta. This one is E minus sin theta. Now you can see, because at point P it is at equal distance from positive charge and negative charge, so electric field due to the magnitude of electric field at point P due to positive charge and negative charge are equal in magnitude. So E sin, both sign components are equal in magnitude, opposite in direction, so they will cancel each other. So whatever electric field we have at this point P is due to cos component. Whatever electric field we have at this point P, that is due to cos component. So definitely your resultant electric field is in this direction. This is the resultant electric field. Now your dipole moment is, the direction of dipole moment is from negative charge to positive charge. Okay. So here you should notice one thing, at point P, which is on equatorial line, at point P which is on equatorial line, your electric field, resultant electric field is in opposite direction of electric dipole moment. Okay, so electric field and dipole moment are in opposite direction for any point on equatorial line. Clear? Consider an electric dipole of dipole moment P is equal to Q into 2A. The line passing through center of the dipole and perpendicular to its axis is called equatorial line. Thus, dipole has infinite equatorial line. Okay. At point P, electric field due to positive charge, magnitude of electric field due to positive charge, and magnitude of electric field due to negative charge, that is 1 upon 4 pi epsilon naught charge q square of the distance. So your distance is under root r square plus a square. Okay, so square is r square plus a square. This is the magnitude of electric field. Now you can see as shown in figure, E plus sine theta and E minus sine theta cancel out each other. So at point P, electric field is due to cos components. Okay, so resultant electric field, magnitude of resultant electric field E plus cos theta plus E minus cos theta. Okay, but magnitude of electric field of positive charge and magnitude of electric field of negative charge are equal. So it is 2 E plus cos theta. 2 magnitude 1 upon 4 pi epsilon naught q r square plus a square. Okay, and cos theta, from figure cos theta is adjacent side upon hypotenuse. So your adjacent side is a, hypotenuse under root r square plus a square. Okay, so thus we have 1 upon 4 pi epsilon naught q into 2a upon r square plus a square. So now the power of r square plus a square is 3 by 2. Here r square plus a square has power 1. 1 in multiplication addition of power. So 1 plus half 3 by 2. Okay, so this is the magnitude. So in vector form, electric field on equatorial line 1 upon 4 pi epsilon naught q into 2a is electric dipole r square plus a square raised to 3 by 2. Okay, and you can see the direction of electric field is in opposite direction to dipole moment. So minus p cap. ठीक है, clear? Now special case, if r is very greater than a, then r square plus a square is almost r square. So r square raised to 3 by 2 r cube. Thus we have electric field 1 upon 4 pi epsilon naught p by r cube minus p cap. क्लियर? सो पॉज करो और पूरा क्वेश्चन ध्यान से पढ़ लो. बराबर इस तरह से आपको रिप्रेजेंट करना है. प्रेजेंटेशन भी बहुत इंपॉर्टेंट है. आप लोग सिर्फ मैथमेटिकल स्टेप से लिखते हो. पॉज करके पूरा पढ़ लो. ओके, The next question we are going to discuss state and prove Gauss law for electrostatic. Okay, so Gauss law gives electric flux passing through closed surface. Okay, Gauss law gives electric flux passing through closed surface. So Gauss law gives electric flux passing through closed surface. Okay, statement. Electrostatic flux passing through closed surface is ratio of algebraic sum of electric charges enclosed and permittivity of free space. Clear? Electrostatic flux passing through closed surface is ratio of algebraic sum of electric charges enclosed and permittivity of free space. ठीक है. So mathematically flux phi, which is integration E dot ds, but this is for closed surface, summation q by epsilon naught, where summation q is algebraic sum of electric charges enclosed. Algebraic sum means sum with consideration of sign. Here in this algebraic sum you have to consider each charge with its sign. If it is positive, consider positive. If it is negative, consider negative. Okay. Now let's discuss proof. ठीक है. Suppose consider this spherical surface of radius r. At the center of this spherical surface there is charge q. Okay. Now we have to consider this area, the surface delta S. it is in radial direction. Electric field is also in radial direction. Clear? Suppose point like charge is there at center of spherical surface of radius r. Clear? Consider a small surface element delta S. Okay. Flux passing through this element, suppose it is delta phi. So electric field E dot delta S. Now it is electric field of point like charge 1 upon 4 pi epsilon naught q by r square r cap dot. Now you can see area vector is also in radial direction. So delta S can be represented as delta S into r cap. Now r cap dot r cap 1. So we have 1 upon 4 pi epsilon naught q by r square delta S. So therefore total flux passing through given spherical surface phi summation delta phi. तो 1 upon 4 pi epsilon naught q by r square, ये सारे कांस्टेंट है बाहर, समेशन डेल्टा एस बराबर. अब सारे एलिमेंट का एडिशन करूँगा तो मुझे टोटल एरिया ऑफ द सरफेस मिलेगा. तो 1 upon 4 pi epsilon naught q by r square और ये हो जाएगा total area of the surface. It is spherical surface, so 4 pi r square. So thus we get q by epsilon naught बराबर. तो ये हुआ गॉस लॉ. नोट डाउन कर लो, पॉज करके पढ़ लो. पॉज कर लो. Okay, now important points about Gauss law. ठीक है, तो फर्स्ट ऑफ ऑल इट इज applicable to any closed surface. So shape and dimensions of closed surface are not important. Okay, the only thing is it should be closed surface. Okay, it should be closed surface. Second thing, flux passing through closed surface does not depend on area or shape of the closed surface. Listen, flux phi is q by epsilon naught, but if it is closed surface. Now you can see there is no any variable in this formula. It depends on only charge enclosed. Clear? So flux passing through the closed surface depends on charge enclosed only. It does not depend on area. So suppose you are asked that the Gaussian area of the Gaussian surface becomes twice. What will be the new flux? Definitely flux will not change, because according to this flux, as far as flux for closed surface is concerned, it does not depend on area. ठीक है? Here summation q is algebraic sum of all charges which are enclosed by closed surface. Charges outside the closed surface are not considered. Here in summation q, you don't have to consider the charges which are outside the closed surface. But flux phi close integration E dot ds. Here E is resultant electric field of all charges, whether enclosed or not. ठीक है? Then with the help of Gauss law, we can find electric field for symmetric charge distribution. If we are given symmetric charge distribution, then we can find electric field. Okay. Gauss law is special presentation of Coulomb's law. It proves that Coulomb's law obeys inverse स्क्वायर लॉ. तो ये भी इम्पॉर्टेंट क्वेश्चन है, मेरा पॉज करके पूरा रीड कर लो.